In this video, I will talk about the second periodic trend, atomic radius. And well, as the name states, the atomic radius is just the distance from the nucleus of an atom. So this will involve ions. So first I'll just use a periodic table. So I'll say the trend and then I'll explain why that occurs. So the trend for atomic radius is the same as the trend for metallic character. It will increase from right to left. That's a horrible arrow, you can see. And it will increase from as that. So going down a period. So if you're able to remember the trend for metallic character, which is just like looking at the periodic table and knowing this side is metals and this side is non-metals, you can remember the trend for atomic radius pretty easily. So why this occurs can get a little complicated, but I'll try to make it as simple as possible. First of all, let's start with the vertical arrow. So it increases from up to down. So if you remember from when I talked about quantum numbers and electron configurations, you can remember the n increases like that. So 1, 2, 3, 4, 5, 6. That will be 7. And that will be the value of the n for, or the principal quantum number for all of them. So like that's why you start with like 1s2, 2s2, and so on, because the coefficient is the quantum number, the principal quantum number n. So what n represented was a further energy state, so higher energy. Let me fix this, it looks like an H kind of. So n, and it represents a greater distance from the center of the atom. So that distance, in this case for that atom, would also increase the radius of the whole thing. So if you have a helium atom just enclosed, the atomic radius is not that big. It's right here. It's pretty small. You can see it's probably the smallest. Yeah. And when you compare it to something like francium, which has the biggest atomic radius, it's going to be an enormous difference. It has first of all, helium has an n of 1, as you can see from here, and francium has an n of 7. So the distance from the nucleus will be like huge when you compare both atoms. So that's pretty much how you know that it increases as it goes down, because it will have a higher energy state, and as the n increases, the distance also increases, so it will be further away from the nucleus. Now for this trend, you have to take into account the charge. Well, not really the charge, because I mentioned it's an atom, but the attraction that builds between the electrons and the nucleus. So we know that when we go from left to right, the atomic radius increases. So not the atomic radius, sorry, the atomic number increases. So we have a 21 here, a 22 here, and then we have a 27, 29, and so on. So it all increases as we go from left to right. But the noble gas core stays the same. So like when you can think of this as the noble gas notation used in electron configurations. The noble gas will still be the same for that, but that doesn't really matter for now. There will be more attraction between the outer electrons and the positive nucleus as it goes from left to right, not from right to left, from left to right. And what that means is that if there is more attraction, it's like, let's say, fluorine, that it will try to pull it down into the nucleus. We have an electron here, or as many electrons. I'm not using the actual number. I'm just showing you how it works. So it will try to pull it down to the nucleus here and make the radius smaller. So our fluorine would be really small. But when you compare it to something like potassium, which is to the left, very to the left, it's a metal. I need more space. First of all, we know that the radius is bigger because of the higher end, and because the electrons are so far, it's not as easy for the nucleus to pull it down, making still potassium bigger than fluorine. So as the like potassium is here, fluorine here, so from right to left there will be less attraction between the outer electron and the nucleus, making the atomic radius bigger. If there's no attraction, there's nothing making, like, pulling it down closer into the nucleus. So the radius will stay the same, let's say, and that will make it big compared to the ones that actually get pulled down, like the non-metals. And well, that is atomic radius. It's the same as metallic character. If you are able to remember metallic character, you will remember atomic radius. And if you found the video helpful, like it and share it with your friends.